All right, we're going to begin our geometry unit with a couple of pretty quick lessons. One is triangle sum theorem, which I do believe that you've had in the past. The triangle sum theorem is pretty easy. It basically says you have three angles in a triangle, and across the three angles in that triangle, you would simply add them up, and they always add to equal 180. Now, I don't think this is new at all, so simply 81 plus 73 plus 26, if you add those up, you end up equaling 180 degrees. That is pretty quick, pretty simple. There's a couple of things that I need to point out just to make sure that you guys can see all the figures that you need to see and you know what to do. A couple of reminders from our section on the basics. An equilateral triangle. I want to talk to you about equilateral. The prefix equa basically means equal. Lateral refers to the sides. So if you have three equal sides, it also has three equal angles. Okay? So if everything adds up, and this M right here stands for measure. So basically the way you read this is that stands for measure. That symbol right there is the angle symbol. We always use a lot of shortcut notation in geometry. So we're simply saying the measure of angle number 1 plus the measure of angle number 2 plus the measure of angle number 3 would all add up to be equal 180. I also want you to know that I would use a mark. It's called a tick mark, or sometimes it's just a slash. And if you see that mark, that means that this side is of this length, and if this side has the same mark, then it's of the same length, and if the third side has the same exact one mark, then it has the same length as well. And it turns out if you have three angles and they're all the same, each one's going to equal 60 degrees. This one's 60, this one's 60, and this one is 60. So pretty much every angle in an equilateral triangle is 60 degrees. They're all the same. But again, I want you to be familiar with what happens and what you need to know when you see those marks on the triangles. Those straight hash marks or tick marks, they have meaning. All right. Now, I know the answers are here. I'm going to kind of pretend that they haven't worked everything out because I want to make sure that I show you what you need to know. All right. Again, they're looking for X, X, and X. What did I just say you need to pick up on? You know what? There's a straight mark on this side, a straight mark on that side, and a straight mark on the third side. That means every side is the same length. So if they're the same length, all three angles are also the same. So kind of keep this in mind. Three equal angles, or three equal sides. That didn't sound right. If I have three equal sides, okay, it also means I have three equal angles. Three equal sides, three equal angles. All right, example number 2. What if I know that I have three equal sides, and we've already figured out that each one is 60, 60, and 60. Then it says find X. So if I want to find X, well, I know that the 2X minus 12 angle, which that's an expression that they've used for angle, if you set that equal to 60, then you can simply solve. And they were able to solve and reason that X is equal to 36. All right, we've mentioned equilateral triangles. Now we're going to talk about isosceles. Isosceles triangles have two equal sides. All right, equilateral had three equal sides. Isosceles has two equal sides. All right, up here we have three equal sides, which meant three equal angles. It turns out two equal sides actually means two equal angles. Two equal angles. But you have to be sure that you know which two of the three are equal. So I'm simply going to go to my picture and I'm going to take a look right here. I have a tick mark on that side and that side. So I know that it's this length and this length on those two sides that are equal. The bottom side is not necessarily the same. It is going to be the sides or angles opposite of those. So if I have this side here, the angle that's opposite from that would be the one in the corner. And if I had the side opposite from this other length, then it would be opposite from that, and it would be the one over here in the corner. So it's always going to be the angles opposite from the sides that are the two that are equal. So that's where x and x would be. And so I could simply say x plus 30 all adds up to be equal to 80, which is where they got adding x plus x. They set it equal to 2x plus 30 equals 180. All right. Now, looking at the fourth example, just to be sure that you're able to kind of interpret what you see here, this side has one tick mark, this side has one tick mark. That means that the angle across from that side and the angle across from that side, these two angles are the same measure. Normally we'd put like one arc mark on each one, because one arc mark on each one would indicate that those two angles have the same measure. So that tells me that this angle, 2x minus 27, is equal to that angle, x plus 53. And of course, that's how they set it up and solved it. Again, I know the answers are there, but I want to be sure that you pick up on the fact that there are ways to take notes. The little marks on the sides of the triangles, those have meaning. Pick up on those marks. If you've got 3 marks, you have all 3 sides the same. That means you have all 3 angles the same. If you have 2 marks, it means 2 sides are the same. And if you have 2 sides that are the same, then the angles across from them or opposite from them in the triangle are also the same. 3 equal sides, 3 equal angles. 2 equal sides, 2 equal angles. Pretty quick, pretty easy. All right, you have a few selected problems. I think I trimmed them down to around 10, 12, so you don't have that many. All of these should be very easy to figure out. You just simply set them up. For example, number 3, I see 60. This mark here always indicates 90 degrees, and then you're looking for x. So I would simply say 60 plus 90 plus the x equals 180. If you add the like terms, you're going to get 150 plus x equals 180. And if you subtract 150, you're trying to get the x by itself. It turns out x is going to equal 30 degrees. Hopefully, those are pretty easy for you to see. All right. So when you do number 5, do you notice number 5 has one mark here and one mark there? And it's already got x here and x here, so I know this angle and this angle. I can put one arc mark on those. Those indicate those are equal. Can you figure out how much each angle is worth? Again, you have an example. When you get to the ones that have, like number 9, number 9 does not have the marks, or it does have the marks. It doesn't have the information in the triangle. But it's telling me the measure of angle I is 48. So I know I'm going to come up here and I'm going to put 48 for I. These marks here tell me something that I really need to know. I have 2 equal sides. Does that mean I have 2 equal angles? So the angle across from that side is there, and the angle across from this side is here. It means this and this is the same. So whatever I can figure out for the measure of angle T would be the same as the measure of angle S. Can you find the measure of angle T? I'm not going to finish that one for you. Again, I just selected, it looks like about 13, and a couple of them are already worked out. When you have an expression, for example, number 10, I know the answer is there. Let's just pretend that we don't. I have this angle plus this angle plus this angle. I have no tick marks, but I know that if I add them all up, they should all equal 180. So I'm going to add x plus 2 x's plus one more x. And x plus 2 x's plus x should be 4 x's altogether. I don't have plus anything here or plus anything here, but I do have minus 16 here. So I have added everything together as far as the algebraic expressions. X's were added to x's, and the numbers were added as well. I know that that total should equal 180. And of course, you would solve. I'd move 16 over here, adding 16 to both sides. And I get 4x is equal to 196. And of course, the solution turns out to be 49. It's not that I'm trying to circumvent, I just want to make sure that you approach the problem the right way. For example, in 13, if I have x and another x here and another x here, can you tally up all of the x's? All right. Can you look at the numbers? Can I add 21 and then add 61 more and then add 23 more? Can you add up all of the x's and all of the numbers? And can you set it equal to 180 and then solve the equation? So we are working with triangles, but we are still doing algebra problems as well. I'm going to stop there because this assignment is very brief. I think it's something you've done before, and I don't really want to labor and go through anything else. But this should get you a good start on getting this side of the homework finished or classwork finished.